Mister,
Yes.
can I ask you a question about the midterm?
Yeah, go ahead.
Uh, if we have answered without any justification, it was 0 point.
No, I changed my mind
Okay.
because yeah, if I could have given like a very low grade for many people because justifications were not there or bad or yeah. So I instructed my graders to be quite generous. Yeah. So don't worry. Yeah, I did send so all the grades now, the grades for the midterm and the problem set, and so oh yeah, I can tell you what the average of the whole thing is. Yeah, it's so for the two groups, so all the groups together. So I don't know which group is which. So 10.8 for the midterm, 13.65 for the problem set, and so in total it's 11.3 for the TD grade. So that's a half your note. Yeah. So for most people it's decent. It's not exceptionally good, but yeah, I think my grades are slightly higher than they were before I started teaching the class. So yeah. So some people are in trouble, but most people they can do perfectly well if they do decently well at the final exam. Okay, so
Okay,
let's
thank you.
yeah. So let's start. How many are we now? 35. Because we ended with the quiz, right? And the quiz I've got 12 12 people. So yeah, I think it might be a good idea to allow you to do the quiz again for the people who didn't have time to do it. So let me just tell you what's important for the quiz briefly, and then you can answer. So it's not a difficult quiz. Where is it? Let me share my screen. Okay, so this was the quiz. So just a reminder of what we did last week. Yeah, so we did the Kagan model, or not last week, but yeah, Tuesday. Yeah, so what's important in the Kagan model to know? Well, first of all, you have to know the equation of exchange, which describes how much money supply you need, M, as a function of what is the number of goods you have to exchange, Y, and the price level. So what is the nominal number of goods you need? So then this dictates how much money supply you need and the velocity needed to exchange it. So the velocity is, of course, how fast the same amount of the same money, if you want, is going to circulate in the economy. And it captures everything that needs to make these two sides balance. And this is, of course, in nominal terms. So it's in euros, for instance, and this is in euros too. So V has no units. Okay, so that's the first step. Second step to know is what dictates velocity. So in Kagan's model, velocity is dictated by nominal interest rate. So it could be dictated by other things. If so, we could imagine that there are other ways to store money. So if something else gives a link between velocity and and the cost of keeping money in your pockets, then it could be fine too. But here, Kagan, in Kagan's mind, the link that is quite important is this one. It's the link between velocity and nominal interest rate. And how does that work? So alpha here is positive. Can be it can have any positive value. We're not saying. And why do we have this link? Well, simply because if I can go to the bank and receive a very good interest on my deposit, then I want to keep with me my money in my pocket as little time as I need, so I can run back to the bank and put it in the bank and have a good interest in my money. All right. And this nominal interest rate is actually the combination of two things. One is the real interest rate, and one is the expected inflation. So why is it the case? Well, of course, nominal interest rate is what the bank decides that it's going to give you for your loan, but the bank doesn't decide this at random. So there's a market for loans, or there's a financial markets. Now we don't describe them extremely explicitly, but in the back of our mind, there's this fact that the bank has to give some real interest to convince people to deposit the money in the bank, and has to care about the fact that there is a cost to depositing money in the bank, which is the expected inflation. So if there's people expect 25% inflation, then there's no way that the bank can give just 10% nominal interest, because what it means is I'm going to lose money if I do that. So the bank has to give more. So it has to give maybe 30% or more. So if expected inflation increases, then nominal interest has to increase, and this will increase velocity. So that's the Fisher equation of interest. And finally, so what we do is we simply solve this. Well, we substitute R and expected inflation here, and we can substitute then alpha times R plus expected inflation into our money demand. Or actually, yeah, rather we're going to get rid of things that we don't care in the money demand and use it to substitute it in our Fisher equation. And that's how we get the solution for the Kagan model. So I'm not going to go redo again all the derivation of the Kagan model. Simply, you have to express expected inflation time t and time t minus 1. And you get this expression there. So that's what we got last Tuesday. All right, so with that in mind, and the conclusion that we have seen is that prices are a function of different things. They're a function of, well, use this thing here. So this version here was a version with simply no interest and no output. We just want to say that this is 0, this is in log. So it means that basically we don't really care about the change in real GDP and the change in real interest. For short periods of time, it changes quite slowly. But as we have seen in hyperinflation episodes, prices and money supply can vary very quickly. So we say that these things are essentially 0. We cannot care about them. And this is the version that we care about. And what we see is that prices today are a function of prices yesterday or last period, plus the change in money supply, plus money supply today, and also a function of money supply the last period. So what's interesting in the Kagan model is because of this link that we've seen with velocity and nominal interest rates, that go through this expected inflation channel, then the change in price today is going to affect expected inflation and change in price tomorrow too. So basically, we have a more complicated solution than we've seen in the beginning of the lesson. So the beginning of the lesson last week, we saw that there was just a long-term link between price and money. But in the less long term, so in the more short term, since we have expectations that kick in, you see that there is also, so it's basically the change in money in the prices is going to be dictated by the change in money supply. It's not exactly, yeah. We could rearrange the terms to look at the change over time and the change over time. Here is the canonical way to deal with it. All right. So now I would like, yeah, let me skip that. So here's the quiz. So think about it for 5 minutes, or if you haven't tried it, go on the website and answer it. I'll give you a few seconds to do it. I gave you most of what you need to answer it. I went pretty quickly because of course it's review material. For those who already did it, then I can already tell you. So I've had very few requests for stuff to see this class because yeah, I'm not. So we're not going to see this this thing for long. Just maybe 15 minutes more or 20 minutes more, and then we're going to review questions. And the most popular topic by far is chapter 2. So yeah, we can do chapter 2 again. Yeah, so yeah, in chapter 2, we're going to see, of course, the Easter Island, which is the most challenging part. I am designing an additional exercise, which is a sort of auto-evaluation like I did for solo. So some extra exercise to do on your own. And I'm going to give that to you. And so what I want to do is, I know that you guys are busy with other stuff right now, but when we get closer to the exam, you might wish that you could ask questions. So I want to give you this auto-evaluation, and you can do it on your own. And then close to the exam, I'm going to create some extra, maybe an hour and a half, or we'll see how much time we need to answer questions that you may have about previous year's exams, about this auto-evaluation. So I'm sure you're going to think of many questions when we get close to the exam. By the way, the exam is December 15th, I think. It's on a managed exam.
Sorry, I have a question about the final exam on managed exam. Will it be a quiz or exercises that we will have to take picture of and then?
I don't know yet.
Okay.
It depends on what inspires me when am writing it. Yes, what the type of exam I really like is the sort that has two characteristics. So one is it's easy for us to grade, and two, it's very good to see which student really understand. And by really understand, what I'm saying is I know that when you write your answer, you had to understand how to solve it. So usually the kind of exercise I would give is some exercise with that you would normally do with letters, Greek letters like alpha, beta, or B, or whatever the problem is, like this Kagan model, for instance, or the Eastern model, or the fish model, but with some numerical values. And then I would give you some so that it would be a sort of multiple choice exam, but the choice is the answer 0, 1, 2, 3, 4, or if even I can give you answers that are not all numbers, so that would be like, is the answer between 0 and 1, between 1 and 2, between 2 and 3. So that way there's just no way that somebody can fake understanding it and not understanding it. It's pretty clear. If you understand how to solve the problem, then you can do it and answer it well. And then for us, it's easy. If the answer is good, then it's good. If it's bad, it's bad. But yeah, I don't want to commit to any special style. It depends how things goes.
Okay, thank you.
Okay, a few minutes to finish the quiz. So it's really not a extremely tricky quiz. It's applied what I just said. So it's a memory quiz. Okay, so let's correct the quiz. Okay, yeah, most of you did well. Okay, ceteris paribus, meaning if taking everything as given, if expected inflation goes up, how does velocity change? Is there some, oh, well, it looks like, okay, I'm hiding this. So does somebody have a suggestion? Let me put that full screen. Yeah. Oh, well, you can see it. So it goes up. Why? Because if expected inflation goes up, then nominal interest offered by banks will go up. So people will want to keep the money with them as little as possible. So then they will want to go back to the rush to the bank and put it in the bank. So yeah, 95% of good answer. So just one, but I'm sure it's just a misclick. Okay, number 2. No, I have this this thing in front. Okay. Ceteris paribus. If real interest rate go up, how does velocity change? Suggestion?
With the equation?
Yeah, so just what do you think in using what I just said?
It goes up.
Yes. Why?
Because when the real interest change rate change, so velocity change too. I mean, where IT is equal to RT plus inflation, expected inflation. So when RT increase, IT increase too, so velocity increases too.
Yes, so this is a good mathematical description of the formula, but so why did Kagan think that this formula made sense? Well, it's again because if real interest rate goes up, then it means that it's costly for me to keep my money, so I want to put it in the bank. So you see that in a way, so I could have had a function of velocity and the price of any other asset that I can keep my money with. So for instance, gold. So if the price of gold goes up, then it goes up over time. I mean, so I know that I should put all my money into buying gold because the price is going to go up. Then it's going to increase the velocity of money too. I'm going to sell some gold and do my transaction real quick, buy milk and butter and bread, and then buy gold again so I can, or if I know that Bitcoin is going to go up next month, then I want to put all my money in Bitcoin and keep my money as with me as little as possible. So that's here. It's the link is with real interest. It's less risky than Bitcoin. So we assume that it's a risk-free rate. Yeah, so yeah, everybody got it, or almost everybody. Ceteris paribus, thinking about the equation of exchanges. So if velocity goes up, how much prices adjust? Suggestion?
Prices should increase too.
Yes, because on the one side, on the right-hand side, it's nominal GDP, and on the left-hand side, it's velocity times the money supply. So if so what is the so if velocity goes up, so the left-hand side goes up, so the right-hand side needs to go up too. So prices need to go up. Yes, good. Ceteris paribus, if real output goes down, how must prices adjust? No idea. Well, it's the same as before. So here, what I'm saying is I don't want to adjust money supply or velocity. I'm saying if these two are fixed, and there's just prices that adjust. So if real output goes down, then so nominal output has to stay the same. So if real output goes down, then prices go up. So it's yeah, and most of you got it. Good. Is Kagan model coherent with the money facts viewed previously?
Excuse me, could you explain why if real output goes down, then net output should remain the same, please?
Nominal? Oh, it's because I said ceteris paribus. So everything's staying the same if only these two things change. But of course, I'm not saying that that is absolutely going to be the case. It's just because we have to assume some things if we want to. Yeah.
Okay, thank you.
So does somebody have an opinion for 5? So this It's more something that you can answer if you saw the class on Tuesday. All right, so
maybe I have something.
okay, good, go.
It's not coherent because Kagan model we can have hyperinflation, and we have seen that in Zimbabwe or in Zimbabwe or Weimar Republic they were hyperinflation.
Oh, so you're saying in the Kagan model we cannot have hyperinflation?
Yes.
Well, it's complicated. So the Kagan model is complicated. But so you're right that we can have episodes of hyperinflations. So I'm going to be more precise when I. So let me just see what the answers are. Yes, no, maybe, no, I don't know. Sentate su mi cara, por favor. I'm not going to translate that, pero podría ver quién estudiante habla español, entonces podría ver, pero. All right. So let me explain what I'm meaning about the hyperinflation. Okay, you're seeing the slides again, right? Stop me if you don't. Yeah, so this is the dynamic of the Kagan model. And what is Kagan's point is that a change in monetary supply today can have an effect on expected inflation tomorrow. How? Because inflations are expectations are adaptative, and this is the way they are. So he says that the amount of inflation I expect for tomorrow, for next period, is a weighted average of, so a lambda here is between 0 and 1, of what I expected as inflation today, and what was the real inflation today. This is E for expected, but this is the actual inflation, so the change in price today compared to yesterday. So today I see how prices changed, and then it makes me guess how prices are going to change. And if I use this equation, yeah, so this is how I derive the whole model. And what I can see is that then the impact of price yesterday can be reflected in the impact of price today. And you could imagine, so that this is is very large. It could be close to 1, or even larger than 1. And if this, because it could be negative, for instance, but yeah, I don't want to spend too much time on it because it becomes a very strange model. But you could imagine that if this coefficient was larger than 1, then it means that if I have higher prices yesterday, then prices today are higher, even though, even without change to the money supply, for instance. And then you could get hyperinflation just because of expectation. So people expect prices to go up, so they want to get rid of their money as fast as possible. So then this affects prices even more. So then it affects their expectation of inflation even more. And you see that this is a crazy cycle that can create hyperinflation on its own. And that was Kagan's point. But it's not necessarily coherent, or doesn't describe the same phenomenon as the money fact we've seen earlier. Why? Because what we've seen in the money fact earlier is the following. we've seen a one-to-one correspondence between inflation and money growth. So it looks like you cannot have prices that starts to go crazy on their own without a following increase in money supply on its own too. At least for large periods. So here it's for example the 60s to the 90s. So why is that the case? Well, it may be that people don't react as much in terms of velocity to nominal interest rate as Kagan assumes. It might be because people don't adjust their expected inflation all that much with what happened today. But also it might be because there is a link between inflation and money supply. And what would that link be? Well, for instance, if inflation goes up, as we've seen, there's the Oliveira-Tanzi effect by which governments try to collect taxes, but then when they're done collecting taxes, the prices have gone up so much that the real value of these money balances are very low. So they don't have enough money to finance the state and the government programs. So then they start printing even more money. So that's a link between inflation that goes from inflation to money growth. We usually think, oh, I emit money, I increase the money supply, so prices go up. So it should be a link between money supply and inflation, but there might also be a link between inflation and money supply through this Oliveira-Tanzi effect. But this effect is not described by the Kagan model. Kagan model assumes, in Kagan model, you usually assume that money supply is exogenous. All right. So it's not coherent, but it doesn't describe the same phenomenon. So that's why it's not, it's not the kind of question I would ask in the exam, because it's a more open-ended question. It's a question about how do you interpret facts. So very quickly, yeah. So and why I'm a bit so I'm back to with the Kagan model, and why I'm a bit skeptical about it, about this thing, is that to have this larger than 1, the only way is, you see that if this is positive, 1 minus alpha, 1 minus lambda is positive, then since lambda is smaller than 1, then for sure this is positive but smaller than this. So the coefficient of pt minus 1 is smaller than 1. If this the whole fraction was larger than 1, then it would be because alpha is very large, and then 1 minus alpha times 1 minus lambda is negative, which would give me something that is even more negative here. So I would have a larger than 1 coefficient. So that's how I could get this crazy amount of inflation that go on its own without a following increase in money supply. Why that is weird is that you can see that if this coefficient here, if this 1 minus alpha, 1 minus lambda is negative, then this too is negative. So it means that the increase in money supply today decreases prices, which is sort of the opposite of what I've been telling you all along. So what that reflects is how this type of modeling, in which you don't have real micro foundations, is it's an old model, but it's good for you to see where macro was back in those days, and why we don't do the things we do, the things the same way we did back then. One thing that we do change is the way we form expectations. So here we have adaptative expectations, but one thing that is much more popular in today's models is rational expectations. By rational expectations, we say that people know for sure what is going to be the inflation tomorrow, so we cannot fool them in any ways. but that is something you're going to see in your next macroeconomics class. All right, so yeah, one thing that's amazing about Kagan model is that he did try to estimate it, and this is a model in the 50s. So I mean, computers have been invented or created like in 1944 for the Second World War. So this is super early, and still he was able to estimate this model. So that this is a great feat in itself. It was a very groundbreaking paper when it came out. So this is his data. So he has the data on all these hyperinflation episodes of the past. Russia, Poland, Hungary, 2 episodes. For them, they had 2. So they had one after First World War and one after the Second World War. Greece, Germany, Austria. This is the average inflation rate in percentage per month. And this is the real balances. Oh yeah, so this is the, okay, yeah, the minimum level of real balances. So real balances meaning that you divide them by the price level compared to their level before the start of the crisis. So don't get too scared about this. This is just to explain you the exercise, but as I said, it's all econometrics. It's so today we would do things differently, but I just want to show you the whole estimation. Oh dear, I forgot that. Okay, yeah. So with these, so what he does here is a simple linear regression. Well, not exactly linear regression in the paper if you look at it, but you can interpret this as a linear regression. So it's just he models price today as function of price yesterday, money balances today, money balances yesterday. And then again, so M here is this real balances minimum compared to initial. Yeah, and he estimates these coefficients, beta 1 equals this, beta 2 equals 1 divided by this, and beta 3 equals 1 divided by this thing here. And for most countries, we see that there's a positive but smaller than 1 coefficient for beta 1, meaning there's no hyperinflation. But for 2 of them, Russia and Germany, so we see this that there is this negative value of 1 minus alpha, 1 minus lambda, which leads to a coefficient of beta 1 that is larger than 1. So it looks like in these episodes, the money supply just went crazy on its own. Not the money supply, but the price level. Yeah, so here, this is the value of alpha that we deduce, and then we can deduce the value of lambda too. But yeah, don't waste too much sleep on this. This is just to show you his exercise. So in Kagan's view, it looks like in Russia and Germany, there was really hyperinflation, meaning that the price level exploded without a corresponding change in money supply. Whereas in the other episodes, there was a great increase in money supply that explained the increase in prices too. Okay, so this is a good lesson that we have to take home with us. So first of all, so Kagan's in Kagan's paper, he says, so this is something that we have known, that we've really known since the 70s, 80s, and 90s, but still early on, back in these days, you can already see that he already realized that there's a need for discipline. So we cannot let the central bank monetize deficits as it wants. So just print money to pay for government programs, because then people will just lose the ability of the central bank to reimburse their loan with gold, for instance, or if it's floating exchange rates, then the value of the money will just crash. So you need to finance the government with taxes. It shows that expectations matter for hyperinflation. So what if you expect inflation in the future? It can actually self-trigger inflation in the future. So this is adaptive beliefs about inflation. One way to make sure that there is no hyperinflation is to anchor individuals' inflation expectation. So it must be that lambda is high enough. So as you remember, lambda is the weight I place to my previous beliefs about inflation today. So if lambda is equal to 1, then I don't react to what was the actual inflation today. I just trust that this was just a fluke for this year, but next year there's not going to be more inflation. But of course, if lambda is low, then it means that if I see prices changing now, I start to freak out and think that prices will change even more in the future. Yeah, so part of the trick is to have a central bank that has, we say that is hawkish, hawk like faucon. So it means that it's very, very hard, and so it cares a lot about the value of money. So maybe, I don't know if you've seen this, or maybe you're going to see in the other models, but usually we want to model the central bank of the country as having some objective function that it wants to fulfill. And usually it is to keep the price level stable, but also make sure that there is not too high unemployment. And you have to balance these two things. So, but if as a central bank you want to be super credible and to make sure that people know the prices are going to be stable no matter what, then you place a lot of weight on keeping prices stable and not emitting too much money supply. So no quantitative easing. And by the way, some economists are really, really adamant that we should be scared about inflation in the future, and that quantitative easing is dangerous because it just increases the money supply a lot. And when the growth starts to pick up, then maybe inflation is going to pick up. That's not what we've seen in the last years. So in the last years, yeah, inflation has always been very low, even lower than target. But yeah, there's no, we can't really know in the future for sure how it's going to be. If I had to place my money, I wouldn't bet on the hyperinflation soon in Europe, for instance, but who knows? Yeah, so in the long run, yeah, I put that here, but I'm not sure if it's a lesson about the Kagan model and not a lesson about the money fact we've seen earlier. Yeah, there's a long run one-to-one relationship between money, between inflation and money creation. That's really that's the money facts that we've seen earlier. And so yeah, it's this thing is saying essentially that in the Kagan model we say that the other variables such as GDP or real interest rate, they change so slowly compared to the money supply and prices that if we study hyperinflation episodes, then we can just say the change is zero. We can just neglect it. Room for improvement, as I was saying. So these hyperinflation episodes are very strange because if you get that, then it means that yeah, so here what I did is I reorganized the equation of Kagan's model with change in money supply today. And what this means is if I increase money supply today and this is negative, then it means that it would decrease prices, which would be very strange. So don't lose too much sleep on it. That's my lesson. Okay. Yeah. So this I already said. Okay. So yeah. So I want just to show quickly what's happening in Venezuela. So yeah, Venezuela things are quite bad. So what happened? Well, it's they relied a lot on the oil. So back in the Chavez government, they exploited oil a lot, and they used that to finance the government and even to decrease taxes, because they said, well, we have so much income from oil that we don't really need to tax a lot, so we can have generous government programs towards the poor, and we don't need to tax all that much, and we can even redistribute. And yeah, I think they made the price of gas extremely low in the country, and everything was well until there was a crash in the oil prices. So this was the crash. So then what do? Well, you have very little taxes, and plus in the country so what happens usually is when you have some extremely large sector. Let me just, before I forget. Yeah, so oil represented 95% of Venezuela's export, so 25% of its GDP. So that's huge, of course. And so when it crashed, then it glutted the whole government, and also the whole economy, because at some point there is so much income into oil production that it's very difficult for the rest of the economic sector that are not as productive to give a good living for people. So people say, oh, I'm not going to keep working in some other sector like agriculture or anything, because it's even cheaper for Venezuela to sell oil and import food from abroad instead of producing its own food. So when you have this dominant sector, then it gluts all the other sectors of the economy. But so things went bad when it started. Yeah, so the GDP fell. So the oil prices fell by 50%, and the prices increased. The government revenue fell, so they started printing money instead. So M started to go up, and prices started to go up. And they started to cut back social programs, and plus they didn't even have enough money to maintain their oil producing and infrastructure, so it was very bad. Yeah. So this is the stores. So they didn't have enough. They couldn't import anything and even produce anything back more in the country. So the person who answered in Spanish in the quiz, do you understand what this is? Or anybody?
We don't have gasoline.
Yeah, exactly. We know high gasolina. So no, it's it's super sad to see that even a country with such a huge sector cannot even maintain its gasoline supply. So yeah, that was so things are very bad right now. And of course, with the COVID crisis and the falling price of oil again in the world, it's just it's not going to become better. And so what would be the solution? I don't know. But they would need to, if they wanted to stop hyperinflation, they would have to I guess, create some new currency and back it with some real stuff. So right now, I would say the last real thing that they could really do is say, okay, we're going to emit money and we're going to back it with our own oil reserves. They still have some, so that would be a way, like in Weimar Republic, when they backed it up with tangible assets, that was land used to produce agriculture, for instance, and manufacturing. So here, that's something that they could try doing, but they would have to balance the budget, and it's a very tough, very tough thing. Yeah, one thing that they would have had to do in the past, it's a bit late, but if you compare that with another country that became extremely rich with oil, Norway. So the price of oil crashed. So is Norway now extremely poor? No, Norway is still one of the richest country in the world. How did they do that? Well, it was nice of Chavez to say, let's lower taxes and let's create programs for the poor. There's no denying that. Thing is, it would have been also very productive to use the good times in Venezuela when they have money to put some aside for bad times. And that's what they did in Norway. They said, oh, we have tons of revenue from oil. Let's not spend it and let's put it in some fund. And so if you go to Norway, it doesn't look like a super flashy, oh, I like this flag. So yeah, if you go to Norway, it's not, it looks like a clean and modern country, but it doesn't look like, it's not, the things are not made of gold. It's just that they have all these assets that came from their oil revenue, and they said, let's put them aside for future generations. So now their fund is over $1 trillion in assets that's invested in many different ways that make sure that even if oil prices crash, the country is not bankrupt. And so it's so good that if you're lucky enough to become a Norwegian citizen, then you don't really get it, but just with this crazy fun, it sort of means that you inherit $200,000. So I would take it. You become citizen and they give you $200,000. Okay, good. It's not bad at all. So that's something that they should have done. And of course, yeah, one thing that they should do is diversify the economy, but it's difficult. Anyway, so yeah, in the short term too, what probably people are doing there is just use Bitcoin. So Bitcoin might be extremely volatile, but if you have a cell phone, it's less volatile than the Venezuela's currency today. Yeah. Okay, so and one other country to look for is Zimbabwe, but yeah, you can look up Zimbabwe's story. Okay. So are there any questions about this? Otherwise, I'm going to jump back to the Easter Island.
Excuse me, could you just re-explain the last answer for the last question for the quiz concerning the money factors and the Kagan model?
Yeah, okay, so it's
summarized because we are relatively less. Thank
you. Yeah, so so this is my answer. So is Kagan's model coherent with the money fact viewed previously? So in the money facts, we look at a long-term horizon. The Kagan model is interested in hyperinflation episodes, which are extremely quick increase in the price level. So if I say it's incoherent, it's kind of it's true, but it's also not describing the same time horizon. But so still, what I can say is that in the money fact, we see that there's a one-to-one relation between prices and money. And here the Kagan model assumes that prices can skyrocket on their own if this coefficient for p t minus 1 is close to 1. Why? Because that would mean that, so imagine that mt equals mt minus 1, and still if you had a higher price yesterday, then it would mean a higher price today and a higher price tomorrow and the day after that, and you could get some extremely extremely quick increase in prices that would just be driven by expectations. So it's a bit like any asset bubble. So it's an asset bubble, but for prices. But it's like an asset bubble for say tulips in Holland. So some people think that tulips are good, so they buy more tulips today, so the price go up, and then people adjust their anticipation for the price of tulip tomorrow, and they think, oh, it's going to be even larger, so they start buying even more tulip. So their expectation of future prices even increases even more and more and more and more. So what Kagan wants to describe is a way in which prices can escape their anchor to the money supply or to other assets like or to real GDP or real interest rate, for instance. Yeah, but so it's not. Yeah. So the question is, it's not extremely coherent, but also it's describing two different things. Yeah. And also, as I said, this, if it's equal to 1, or if it's, it would mean that, that money supply has a reverse impact on prices, which is very difficult to understand. So you shouldn't lose too much sleep on that. So yeah, if to reassure everyone, what I will do in the exam about the Kagan model and this type of model is to give you some equations like yeah, some building blocks. Like I would say something like, this is the equation that describes the velocity as function of interest rates. This is the equation that describes money demand, or the equation of exchange. And this is how expectations are formed. So use these blocks to infer how such variable is going to change for one period to the next. A bit like what I did in the previous exam. Yeah. So this is the, because so as I said, finance is a tricky topic. How people form their expectations. It's I wouldn't say that somebody has the answer about what is the final word about anything. So here is a Kagan's proposition. It was groundbreaking back then, but now we have other ways to describe anticipations. We have micro foundations. So yeah, all right. Okay, so let's yeah, I spent longer than expected on that, but let us briefly discuss chapter 2. Okay, so I had requests to discuss. Yeah, I think the hard part is so the thing is, I put effort into making videos, so I think they're pretty well explained. So it would have been good if somebody had said something like, "Oh, explain to me this detail that is unclear," for instance, because I could just refer you to the videos to understand well what's going on. So yeah, so for the person who said that they didn't understand, was it about this graph, for instance, or these graphs? Because I explained them in one class where there was not a lot of people. So if somebody tells me, "Oh yes, it's confusing for me, please explain that," I'll explain it. Yes, no, maybe, or because we don't have a lot of time. Okay, I had one request for sure. That was this plot here, I think. So of course, this is more complicated. Yeah. So how to be productive for half an hour and not confuse you?
Can you expand this slide, please?
Okay, so this slide, all right. So this slide is exactly the same as, or not exactly the same, but is in the same spirit as this thing, okay? It's just that, so one first thing that Taylor, sorry, did is to invert resource stocks and labor. So he has labor on the y-axis and resource stock on the x-axis. And also he introduced two things. So first of all, he allowed for some government intervention to raise the price of food. So that sounds weird because usually we don't want to tax food. But in this model, it's good to tax food because otherwise there's overproduction of food and overexploitation of nature. So he did that, and second of all, he introduced a tipping point. So a tipping point is a resource value under which the resource stock is always going to decrease. So here you see that if we are on the left side of this green curve here, then the resource stock, the dynamic of the stock is to always increase. But if we add some threshold, that would be like this, then past this threshold, so if S here would be past this threshold, then it would always decrease. So it will not, this arrow would be reversed. So starting with this thing that hopefully you get more or less. So these are the two changes that he did. So now let me go back to. Okay. So you see now resources are on the x-axis and population is on the y-axis. Otherwise, it's the same model. And then before you had this curve that would have been straight. This would have been the curve for describing for which value of L and S we have the resources stock increasing, and for which value of L and S it's decreasing, and you would have that it's always increasing. So there would be an arrow. I don't know if I can draw an arrow. Yes, I can draw an arrow. Oops. So, and if you have low population and relatively high stock of resources, then the dynamic is such that the stock of resources increases. Then if you have too many people, then the dynamic is such that the stock of resources decreases, right? So these are my black arrows there. And so what we have here is that we have a tipping point, and this makes stuff much more complicated. Before it was just a straight line that was easy to describe. And now it's not a straight line, it's something that looks like this. But it still is the same idea. It's under this line, then the stock of resources increases because you have little inhabitants that exploit the resource, and you have enough trees to regrow the stock of trees. And if so, it could go to if there's nobody on the island. So if L is 0, so we would be like here, and the stock of resources would just grow and grow and grow until it reaches K. All right. But obviously we have people too on the island. And what we also know is that if you have nobody on the island, but you have a stock of resources that is below T, the threshold or tipping point, then the stock of nature goes to 0, even if you have nobody exploiting it. So that's the new the way to describe the dynamic. And now we introduce inhabitants, and what inhabitants can generate is the fact that yeah, you cannot reach K, because if the stock of natural resources increase, then the population L will start to increase. So here the dynamic of the population look as it was looking before. So let me see if I can have let me draw my curves. So let me change. Try to see if I can have another color. Okay, so this is how population changes. So this is if I have lots of resources, and as we've seen, so before it was horizontal, and if I had resources higher than a certain amount, then my population would increase. Well, it's the same thing, it's just flipped. And here I see that if I have resources higher than S star there, then L increases. And if I have resources lower than this level there, then oops, L decreases. Okay, so this is this. And now the question is, how do I put these two together? Well, I can know that if I'm on this side, then the arrow will point down and to the left, so this direction there. If I'm on that side, it's going to point up and to the left. If I'm in that region, it's going to point right and up. And if I'm in that region, it's going to point down and right. So it means that my spiral is looking like this. And if I'm lucky, then I can get to this stable island. Well, S dot is 0 and L dot is 0, and people do not die. But so how do I know exactly this thing? Then I don't. It's they have to simulate them or to compute them. Yeah, I think actually there's a way to compute this curve. Yes, there's a way to compute it analytically. Now that I think of it. Anyways, this is difficult, you know, don't lose sleep on it, but still it's a good exercise to. And by the way, now I'm preparing some supplementary exercise that is going to ask you to draw these arrows, and to put the things where they belong. So it's not going to be easy, but if you succeed in doing them, then you're going to be perfectly ready for the exam. Don't worry. Yeah. So what they show is there's this critical trajectory there. If we start from some point here, then we circle to this point there, stable. If we start over, then we start, for instance, with a population that's extremely large. Then they eat the food so much, so fast, that they crash on the wrong side of the tipping point, and the island goes to 0. So it means that at some point they cut like 95% of the trees, and then the tree population is not able to recover on its own. Before, with no tipping point, there was no way for the island to become a barren island, but here that's the way we get it. Yeah. So this is the dynamic for one island, and then so they show for 3 different degrees of governance. So here is taxes is 0. So in the paper it's not taxes, but I changed it to make it look like the previous model. So I don't know, by the way, why they didn't do that. I think it's better to stick to the previous model. So tau here is ad valorem tax on food. If you introduce no tax, then okay. So if you introduce no tax, it's this here. It means there's little government intervention, and you see that if you start with any of these points here, then the economy will eventually crash at 0. And if you introduce a high ad valorem tax on food, then people are not as much willing to harvest food as if there was no tax at all. And you see that, so this critical trajectory there is much higher. So it means that there's a much larger set of values of L and S from which you may start that still leads you to a stable island in which people don't die and the island can recover. And you see that also if there's a higher tax, then this S star, this steady state value of the resource stock has a higher value. It's 8,000 there. Compared to this value here, which is 6,000. So here people exploit the island much more intensely, and this is a middle point. Okay, so did that help a bit?
Yes, thank you.
Okay, so we still have 7 minutes. So is there any other question on chapter? Well, any question on anything, actually. Because I don't want to start over this chapter. It's no time to do that. No. So let me think of okay, well, I can just explain to you briefly what happened in Zimbabwe. Then so let's say that today's class is more or less what I wanted to cover. So since I have some extra time, let me just go back to something I skipped earlier. So it was the case of Zimbabwe, what happened in Zimbabwe, and why it's going awry right now. Okay, so what's interesting in Zimbabwe is we really see this Oliveira-Taenzi and the effect in action. So in 1990, so the Republic of Zimbabwe was born. Yeah. So people were optimistic initially, like all the new African countries. They thought, okay, they're going to grow on their own, and things are going to be well. But yeah, they had some issues, and they borrowed money, and at some point they were not able to pay back their loans to international lenders. And in many of these countries, what they had to do was go to the IMF. So IMF, for people who don't know, is International Monetary Fund, or Fonds Monétaire International. And what this does is it's an international agency, or I don't know if you could call it agency, or it's a fund. So basically, it's what you do when you're out of money and you say, "Oh, I can't pay my debtor. What do I do?" So you could go bankrupt, but since the international lenders are usually rich investors in rich countries that thought that that Africa would go well and they would make a lot of money, so they don't want to lose that money. So they're pissed when some African country decides to not pay. So they go to the IMF and they say, yeah, please help Zimbabwe by restructuring their debt. So that's what IMF did in many instances. So they went to these countries and they said, okay, the reason why you can't pay back your loans is because you don't know how to manage your economy well. So please let us give you all the money you need to pay back your loan, but then you're going to owe your money to us, the fund. But in exchange, we get to tell you how to manage your economy well. And so what do we think is the best way to manage our economy? Well, of course, it's to copy what the most successful economy in the world does, which is, of course, the United States. So then they try to emulate this. So they say basically you have to dismantle the government and make so some of the advice are good. Basically, you to make sure there's a rule of law, make sure that loans are protected, make sure that contracts are well protected. But in some ways back then they didn't think that each country is different, and you can't just have this look at the US and think that it's the only way to do things. And in most of the cases, the structural adjustment programs were a disaster in the countries that they weren't implemented. And that was the case for Zimbabwe as well. So the economy was going quite bad. Then there was confiscation of land by the rich, from the rich whites, by the black poor. But the problem is, so that was in 2000, but that didn't help because, of course, the owners of these farms, at least they knew how to manage them. And if you just capture something but you don't know how to manage it well, then it's bad for the firm to operate properly. So agricultural production went very bad. So the price of food started to go up because there was a shortage of food. And because of these structural adjustment programs, then the state didn't have a lot of money, so they kind of were a bit loose on money supply. And then also at the same time, the Mugabe government wanted to help their neighbor in their war. And they didn't have, of course, enough money to do that. But they said, oh, well, who cares? Let's just print money. It's everything is going to be fine. Also, there's self-dealing. So in the, a lot of corruption in the government. So many things that went bad. So they had also violations of human rights and the sanctions, but the impact of the sanctions, it's not so clear. But what's clear is all of these things it increased the money supply and decreased the economy. Plus, there was this Olivera-Tanzi effect, so inflation exploded and the government didn't have enough money either to finance its war or to finance the current programs, so they printed even more money. So that's when this inflation started. So you see 10% isn't all that bad, but then it started to increase quite rapidly in the 2000, 2005. So that's what we see by inflation kicking in. It's that all these things happen over time that degraded the economic situation. But still, there was no extremely high inflation. Still, things were going okay. But at some point, people realize, oh, maybe it's maybe I'm doing a mistake by keeping Zimbabwean dollars. Maybe I shouldn't do that. Maybe I should try to get rid of it and or raise my prices at least, because I think the value is going to go down real quickly. So this started to happen here. The prices started to go up, up, up. So this is annual inflation. So you see here 10% is nothing crazy, but then 100%, it's a doubling of the prices level from year to year. So it's started to be bad. And then here there was the real crisis where it's increasing by a huge percentage. And it occurred in really the month of October was the crazy month. So again, the same story as before. The government says, oh, now it's illegal to have inflation. Let's just make it outlaw. So you freeze prices, no effect. And then also they realized that people in Zimbabwe were starting to use other dollars like US dollar, euro, and stuff. And they were restricting that. But then they said, okay, we have to stop doing that. People are just going to do that anyways. So they ended the restriction to use foreign currencies. So the inflation went back to 5% a year. And the growth resumed in 2010. So here what happened is they allowed people to just use something else instead of the Zimbabwean dollar. But in 2019 and 20, there was a economic crisis and the Idai cyclone. So there was a 300% inflation in August. So it's looking bleak. So again, hyperinflation, it's not something that happened in the 1940s in Germany, and it's never coming back. Maybe in Europe and the US, it's not really coming back, but it's not over in many different countries around the world. You can still have hyperinflation. All right, so let's. I'm letting you go to your weekend or other class if you have another class.
Thank you. Bye.
Bye.
Also, one fun fact about the Norwegian fund: we can actually choose kind of democratically where we invest it into.
Okay, good. How do you know that? So, are you from there?
I'm not a citizen. I'm not a citizen, but I'm born here.
Okay.
Here all my life. So.
Well, it's well-managed country for sure.
And everything is made of marble and gold.
Yeah, no, I visited Oslo and I thought, yeah, it's nice city, but you look at it and you just, wow, the richest country on earth, it must like be made of gold and stuff. Yeah, it's okay, but it's
fine.
they have a nice Munch museum. I liked it.
Yes, yes. We're getting a new one.
Oh yeah, okay, good.
Well, okay. Well, bye-bye.
Bye-bye. Have a nice weekend.
You too.